Alright, I am here to hopefully help you guys with these manometer problems. Quiz 6 didn't go so well for most of the class, so I figured if I made a video explaining the thought process behind solving these manometer problems, it would help you guys, especially on test 1. So we're going to start off by noticing that this manometer right here is it has three different parts, or three different fluids inside of it, and each one of those is given by, or the specific weight of each one of those is given right here at the top in the problem statement. And we're also given the point in this left bubble at A as 8 psig. So in this problem, or in pretty much every problem, we need to keep our units consistent. So I'm going to change this 8 psig into pounds per square foot, which is going to be equal to 1152 psfg. All that I did was convert the units from pounds per square inch gauge to pounds per square foot gauge. And this is the pressure at A. So in these manometer problems, basically all you have to do is work them in sections. So from point A, we can find the pressure right here. We'll call that point 1. We can find the pressure at point 1, which allows us to find the pressure at point 2, which in turn lets us find the pressure at point 3, and then at point 4, and then finally to find what the problem is asking for, which is the pressure at point C. So the pressure at point 1 is going to be equal to the pressure at A, which is known, that's given in the problem. This is going to be minus, because we're going in the positive z direction, we're going this way to find the pressure. So when you go in the positive z direction, you're going to subtract the pressures. When you're going in the negative z direction, which would be downward, we're going to add the pressure, because I mean it makes sense, because the further you go down, the higher the pressure is going to be. So the pressure at 1 is the pressure at A minus the distance in between the 2 points of interest, which would be 2 feet, times the specific weight of the water in between them, which is given in the problem by 80 pounds per cubic foot. And we know this, we know PA to be 1152. So when doing the math here, we get 1152 minus 2 times 80, which is 160, comes out being 992 psfg. And that's the pressure at point 1 right there. Now we need to find the pressure at point 2, which is right here. And all we have to do is take the pressure at point 2 is equal to the pressure at point 1. This is going to be plus this time, because again we're going in the negative z direction, which makes our pressures, we add our pressures then, times or plus the distance in between the 2 points, which in this case is 2.5 feet, times the specific weight of the fluid that we're going through, which is given by 50 pounds per cubic foot in the problem statement. We know P1 is 992, so P2 is then equal to 992 plus 2.5 times 50, and that is equal to 1,117 pounds per square foot gauge. Now we're going to move over to point 3. So the pressure at 3 is equal to the pressure at 2, which we just found out over here. It's 1117. So that's 1117. This is going to be minus, because again we're going in the positive z direction, times the distance, or minus the distance, which is 4.3 feet minus 1.2 feet, times the fluid, the specific weight of the fluid that they're traveling to, which is given by 150 pounds per cubic foot. The distance is this distance right here, which is 4.3 minus 1.2. And so the pressure at 3 is going to be 1117 minus 4.3 minus 1.2 times 150, which is going to give us 652 PSFG. And that is just the pressure right there at 0.3. Pressure at 4 in the next section is going to be pressure at 3. We're going down in the negative z direction, so we're going to add pressure. There's the distance in between the 2 points times the specific weight of the fluid that they're traveling through, which for this part is 50 pounds per cubic foot. We know this. We know P3 is 652, so P4 is 652 plus 1.8 times 50. That gives us 742 PSFG. And then finally, to find our final value of PC, and that is just going to be the pressure at 4 plus, because we're going down in the z direction, distance between the 2 points, 2.2 feet, times the specific weight of the fluid traveling through, which is 150 pounds per cubic foot. We know P4, so we can calculate P3, or PC, which is 742 plus 2.2 times 150, to finally give us 1072 PSFG. This is part of our answer. If you noticed in the problem statement, it says determine the pressure at point C in pounds per inch gauge, pounds per square inch gauge, and in pounds per square foot gauge. So we do have the pounds per square foot gauge. Now we just need to find the pounds per square inch gauge, and all we have to do is divide by 144, and we get PC is equal to 7.44 PSIG. And these right here are our answers. This is all the problem's asking for. A few things to note. Just remember, if you're going in the negative z direction, the pressure goes up. If you're going in the positive z direction, pressure goes down. Some other things that people were struggling with, just make sure that you're using the right length in between your 2 points. In this problem right here, we're given the values of specific weight in their specific weight form. In a lot of quiz problems and test problems and things like that, you're going to be giving the specific gravity, which will look something like that. Say it's 1.2. Then in order to get these values over here, which is what we're multiplying by, you have to multiply that times gamma water. You always have to remember to do this. This is very important, and a lot of people forget to do this. But yeah, I think that's it. Hopefully this helped. Hopefully this will give you a good review for test number 1. And yeah, hopefully it helped. Thanks.